Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So I have 5 to the power of x plus 5 to the power of x is equal to 7. Now, 5 to the power of x here, because this is here twice, I'm simply going to factor this out from my left-hand side. So now I have 5 to the power of x times, now 5 to the power of x divided by 5 to the power of x, well, anything divided by itself is simply 1. So I have 1 plus, again, 5 to the power of x divided by 5 to the power of x is 1. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now we're going to simplify what's in the parentheses. 1 plus 1 is equal to 2. So I have 5 to the power of x times 2 is equal to 7. Now we want to go ahead and isolate 5 to the power of x, so I'm going to divide both sides by 2 so I can move 2 to my right hand side. So then these two would cancel out, and I would have 5 to the power of x is equal to 7 over 2. Now what I'm going to do is I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. And so this would be equal to b times log a. And the reason this property is so important is because let's say we have 7 to the power of x is equal to 9, right? So I'll first start by taking the log on both sides. So I have log 7 to the power of x is equal to log 9. And then I can actually move this x to the front by using this property. So then I have x times log 7 is equal to log 9. And then I would divide both sides by log 7 to find the value of x, because now x isn't an exponent, it's a real number. So that's why I'm using this property on 5 to the power of x is equal to 7 over 2. So I'll first take the log on both sides. Log 5 to the power of x is equal to log 7 over 2. And then I can move my exponent here to the front. So now I have x times log 5 is equal to log 7 over 2. Now, if I have something in the form log a over b, another important property of logarithms, this is equal to log a minus log b. And also, if I had something in the form log a times b, this would equal log a plus log b. So in this case, we aren't going to use the second property. We are going to only use the first property, which is log a minus log b. So in this case, a would equal 7 and b would equal 2. So now I have x times log 5 is equal to log 7 minus log 2. All right, so now to solve this problem, what I'm going to do is I'm going to first start by isolating x, because we obviously want to isolate x to find the value of x. So now if I divide both sides by log 5, these two cancel out, and I will be left with x is equal to log 7 minus log 2 over log 5. Now, to actually continue with this problem, I have to actually plug in, or I have to use a calculator to find the values of log 7, log 2, and log 5. So now if I plug these values into my calculator, I get log 7. This is equal to approximately 0.8451. Now log 2, this is equal to approximately 0.203. Oh, sorry, that's not right. 0.3010. And finally, we have log 5. And this is equal to 0.6990. All right, so now all that's left is to plug these values into our original equation. So I have x is equal to log 7, which is 0.8451, minus log 2, which is 0.3010, divided by log 5, which is 0.6990. Now 0.8451 minus 0.3010, that is going to equal 0.5441. And we still have this divided by 0.6990. And finally, 0.5441 divided by 0.6990, that is approximately equal to 0.778. Now, to check, our original equation was 5 to the power of x plus 5 to the power of x is equal to 7. Now we have x is equal to 0.778. So now if I substitute an x, or 0.778 for x, I get 5 to the power of 0.778 plus 5 to the power of 0.778 is equal to 7. Now, 5 to the power of 0.778 is approximately equal to 3.5 plus, again, 3.5 is equal to 7. Now 3.5 plus 3.5 is 7, so I have 7 equals 7. Because this is right, our solution is right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stay until the end of the video, where I have a bonus problem for you guys to try to solve that is similar to this one. Alright, so our problem is 16 to the power 4 plus 16 to the power 4 plus 16 to the power 4 plus 16 to the power 4. So, for our solution, well, our original equation was 16 to the power 4 plus 16 to the power 4 plus 16 to the power 4 plus 16 to the power 4. Now, what I can do from this is I'm going to factor out 16 to the power 4. So now this is equal to 16 to the power 4 times. Now 16 to the power 4 divided by 16 to the power 4 is 1. So I have 1 plus, again, 16 to the power 4 divided by 16 to the power 4 is 1 plus, again, 1 plus 1. So now I have 16 to the power 4 times 1 plus 1 plus 1 plus 1. Now, if I simplify from the parentheses, I get 16 to the power 4 times 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. So I have 16 to the power 4 times 4. Now 16 here, this is equal to 2 times 2 times 2 times 2. And 2 to the multiplying by itself 4 times, that's the same thing as 2 to the power 4, right? Meaning 16 is the same thing as 2 to the power 4. So now, if I substitute in 2 to the power 4 for 16 in this problem, I get 2 to the power 4 to the power of 4 times 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power 4 to the power of 4 here, we can think of a as 2, m as 4, and n as 4 as well. So this would equal a to the power of m times n. So in this case, 2 to the power of m, 4 times n, 4. Now 4 times 4, this is 16, so now I have 2 to the power of 16. Meaning, 16 to the power of 4 is the same thing as 2 to the power of 16. So now, I have 2 to the power of 16 times 4. So, well, now 4 here, this is equal to 2 times 2, right? So now 2 times 2, well, 2 multiplied by itself twice is the same thing as 2 squared, meaning 4 is equal to 2 squared. So now, if I substitute in 2 squared for 4, I get 2 to the power of 16 times 2 squared. Now, when I'm multiplying two exponents with the same bases, let's say I have a to the power of m times a to the power of n, this is actually equal to a to the power of m plus n. So in this case, a is 2, m is 16, and n is 2 as well. So I'll have a to the power of m plus n, which is 2 to the power of 16 plus 2, which is equal to 2 to the power of 16 plus 2 is 18. So 2 to the power of 18 is our answer. So now it's time for our bonus problem. How to solve 8 to the power of 16 plus 8 to the power of 16. And for this problem, we have 4 answer choices. So A, this is a to the power of 32. B, this is 16 to the power of 16. C, this is 4 to the power of 64. And D, this is 2 to the power of 49. Alright, so make sure to stay until the end of the video where I can give you guys a bonus problem to solve. So 8 here, this is equal to 2 to the power of 3, right? So let's try out A. A, what they did was they simply just kept the base the same and added the exponents. So they did 8 to the power of 16 plus 16. 16 plus 16 is 32, so they did 8 to the power of 32. And this is actually wrong. You can't just you can't just add exponents like that. So that is the wrong method. Now, for B, what they did was they kept the exponent the same and they added the bases. So they did 8 plus 8 to the power of 16, which is equal to 16 to the power of 16. And this method is wrong as well. You can't add exponents like that. So it's not B, it's not A. Now, for C, what they did was it seems that I actually don't know this. I do not know how they got this. But yeah, I don't know how they did that. So, but C is not the right way either. And for D, which is the correct method, remember how I said 8 is equal to 2 to the power of 3. So what you have to do is you have to substitute in 2 to the power of 3 for 8. So now I have 2 to the power of 3 to the power of 16 plus 2 to the power of 3 to the power of 16. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So right here, we can think of a as 2, m as 3, and n as 16. So now I have 2 to the power of 3 times 16 plus 2 to the power of 3 times 16. Now, 2 to the power of 3 times 16 is the same thing as, well, 3 times 16 is 48, so now I have 2 to the power of 48 plus 2 to the power of 48. Now, if I factor out 2 to the power of 48 from this, I get 2 to the power of 48 times, now 2 to the power of 48 divided by 2 to the power of 48 is 1, because anything divided by itself is 1. So I have 1 plus, again, 1. 1 plus 1 is 2, so I have 2 to the power of 48 times 2. Now, 2 here, this is the same thing as 2 to the power of 1. And as you can see, these two have the same bases. And when I'm multiplying two exponents with the same bases, let's say a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So these two will add to each other, meaning this will be equal to 2 to the power of 48 plus 1, which is equal to 2 to the power of 49. So 2 to the power of 49 is our answer, which is